In this video, we are going to learn sets. So, what are sets? We are going to learn this in this video. So, what are sets? Sets are the collection of well-defined figures or data or objects. So, well-defined means what? Suppose if we will say that the collection of the group of beautiful students. Beautiful, this characteristics actually we cannot well define it. Who is beautiful? Maybe the appearance, the beautiful eyes, beautiful hairs. So we cannot exactly define who is beautiful. Again, the next is like who is most intelligent student. So if we want to collect the most intelligent person in the world, that also doesn't have any like exact characteristics. We cannot define them. So those things are not those collections are not the set of group of sets. So sets are what they should be exactly well defined. Like if we are saying that collection of students who are whose height are more than 5 feet. Now here we can exactly tell which students are having height more than 5 feet. So these are the sets. Now here I hope you have understood what is set. One more example I am telling you. Suppose I will say the collection of even numbers, the collection of odd numbers. In these examples, we can exactly write the members present in set. Now, how we are representing set? So here we are going to learn representation of set. How do we represent a set? Set means collection of figures. These are called members, data, element, objects. So the elements of any set are written inside the curly bracket. So first, how to represent a set? So set we are representing by a capital letter. So suppose this is a capital letter. By this capital letter we are representing a set. Now we will represent set P equal to whatever we are going to represent. We are putting it inside the curly bracket. Suppose I am saying that the collection of all the vowels in English alphabets. So what are the vowels present in English alphabets? They are A, E, I, O, U. These are the vowels. How we are writing the elements? We are writing the elements putting one comma, separating all the members using comma. So these are the elements of set. The name of the set is P. So P equal to one curly bracket I have made, and these are the elements of the set. Now how many members are present in this element? In this set you can count 1, 2, 3, 4, 5. So this is called the cardinal number of set. So this is called the cardinal number. Cardinal number of any set equals to number of elements present in that set. So here cardinal number will be 5. Now every time it is not possible to count the cardinal number of a set. Why? It is not possible to count to tell the cardinality, because some sets are there which are endless. Like suppose if I will ask the collection of all even numbers. No, there are no end of even numbers. Okay, so in that case, how we will write this? Suppose I am writing Q equal to, I am writing the even number collection. So I will write 2, 4, 6, 8, 10. Now there are no end. So what we are going to do? We will put like these dots. That means they are endless. And this kind of set is called infinite set. What they are called? Infinite sets. Now again, if suppose the numbers you can count, like in this case, you can tell what is the cardinal number? 5. They are, means they have an end. 5 numbers are there. 5 elements are there. So they are finite. We will call them finite sets. Okay. So we have learned two types of set also. Cardinal number also we learned. Finite sets and infinite sets. Now we are going to learn equal and equivalent set. So equal and equivalent set we are going to learn. What are equal sets and what are equivalent sets. Okay, so suppose if two sets are given, like P equal to, I am saying number letters in word East. So what are the letters in word East? E, A, S, T, right? So P equals to E, S, T. Now again if I will say what are the letters present in taste? Yes, the letters present in taste. We will write what? Sorry, this will be curly bracket. Now taste. So T, A, S, T, E. Now here listen students, we don't need to repeat any alphabet. So here T 2 times we don't need to write it. So it will be only T, A, S and E. Now see here, you can see that all the alphabets present here are also in this set. See, T is also here, A is also here, S is also here, E is also here. So those both are what? Equal sets. So these sets are called equal if all the members are same to same. So that means we can write it, we can represent the equal sets by putting equal to. So P equal to Q. This way we will write these are the equal sets. I hope it is clear. Now I am going to tell you what are equivalent sets. Now in equivalent set how we will do? Suppose this is in equivalent sets, simply we will suppose I am going P equal to alpha, collection of vowels A, E, I, O, U. So how many members are there? 5. Cardinal number is 5. Now if I say Q equal to numbers up to 5, natural numbers up to 5. So natural numbers up to 5 will be 1, 2, 3, 4, 5. Now here also you can see how many members are there. There are 5 members. The members are not same, but the cardinal numbers are same. So if the cardinal numbers of any two set is same, then those sets are called equivalent sets. So these two are equivalent sets. So P is equivalent. How we show the equality sign, equivalent set signs? This is the sign. So by this we show that these two sets are equivalent if the cardinal numbers are same. Now we will learn what is null set. So if a set is empty, if no member is there in a set, that is null set, and null set is represented by 5. Okay, we will not put bracket like this. If you are putting bracket like this, that means this is a member. This is also a symbol, 5 symbol. So you don't need to write like this. If any set P equal to 5, that means that set is empty. We can also write it P equal to like this. No member is there. For example, suppose if I will ask any even number which is divisible by 3. No, that one you can say any odd number which is divisible by 2. Now there is no odd number which is divisible by 2, right? If I will say the collection of odd numbers which are divisible by 2, so there are no any number which are odd and which will be divisible by 2. So that means that set will be empty. So that set we will represent like this, empty set. I hope it is clear. Now we will study what is universal set. Now if we are discussing about any special particular property, if we are studying about any set, about any distinct properties, and we are taking a set which is having all the set inside it, that set is called universal set. That doesn't mean that the whole collection of all the objects are called universal set. I am giving you one example. Suppose if I am saying that the collection of all the positive natural number, all the natural numbers, right? The collection of all the natural numbers. So how we will write? Suppose the set equals to collection of all the natural numbers. So we can write 1, 2, 3, 4, 5 like this. Again I will say the set of all the even numbers. So even numbers we will write 2, 4, 6, 8, so many endless. Now collection of odd number. Okay. Now if I am saying that the collection of integers, so the collection of integers will means like this we can write, right? Means all numbers will be there, -4, -3, -2, then -1, then 0, then 1, then 2, then 3, then endless on both sides. So you can see here this set U is containing set A also, set Q also, and set B also. That means U is universal set for these sets. I hope it is clear what is universal set. Now we will learn here methods of writing set. See what we have learned today. Definition of the set, representation and cardinal number, then types, finite set, infinite set, equal, equivalent, null and universal set we have completed. Now we are going to study methods of writing sets. We are going to study two methods here, roster method and set debuilder method. So in roster method simply we are writing the elements of the set. The identities or the elements or the members, whatever you can say, the sets, we are writing simply putting inside the curly bracket. Then this method is called roster method. Suppose I am saying that the collection of all the even numbers less than 10. The collection of all the even numbers less than 10. So I will take one alphabet A equal to. So even number, it will start from 2, then 4, then 6, then 8. Less than 10, that means 10 cannot be there. So this is our answer. Now here we are going, I'll ask, is this a finite set or infinite set? Obviously it is a finite set. And what is the cardinal number of this set? 1, 2, 3, 4. Its cardinal number is 4. So by this way, we are writing the elements inside the curly bracket. This is called roster method. If it is infinite, we will simply put dot 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 like. Suppose if I will say a collection of integers, the collection of all the integers. So here it will be like endless. So minus 5, here I will put dot, minus 4, minus 3. Then here also suppose it will go then 2, then 1, then dot dot, sorry, 0, 1, then it will be endless. So here it is finite or infinite, it is infinite. So here we cannot tell the cardinal number of this set B. So this is the roster method. Now we are going to study set builder method. In set builder method, actually we are defining the characteristics of the set. Suppose if I will say that I am writing the exact value of the set, then I will write it in the form of set builder. Like suppose I am writing P equal to 6, 8, 10, 12, 14, 16, that's it. So P equal to, these are the members of the set. So how we can write it in set builder form? So in this, what we are going to do, we are just simply thinking about the characteristics. What is the exact characteristics of this set, character of this figure? See, all are even numbers and they are starting from 6 and ending at 16. You can think other characteristics also, okay? But the exact characteristics that we are actually just finding out is they are even numbers. They are starting with 6 and ending at 16. So how you can write it? You will write it like this. P equal to x such that. The way of writing is x such that x is an even number, or you can write equal to an even number. Even number. And x is lying, note x is lying between 6 and 16. So we can write x. X is equal to 6. So we will write x is either greater than 6 or equal to 6. So I am writing like this. This means x is greater or equal to 6 and it is equal to or less than 16. So in this way, we will write the set in set builder form. So x such that x is an even number and x is greater than equal to 6 and or less than equal to 16. Again, I am showing you one more question. Suppose if I am showing you one set. Here I am writing 15, 30, 45, 60, 75. You can see here. So here you can see all are what? What is the characteristics? All are multiples of 15. All are multiples of 15. How we can write in this set builder form? We can write it x such that x equal to, what we will write? 15n. 15n. We are writing n. Why? Because we will use it n as, we will put it like this. Now this n, the value of n is what? It is from 1 to 5. So we will write where n lies, it is greater than equal to 1 and less than equal to 5, isn't it? So 15 into 1, 15 into 2, 15 into up to 15 into 5. So in this way we can write. We can also use it in the form of natural numbers, like we can write it like this, okay, as you wish. So I am using this small n only. So 15 and is the characteristics of the set and n lies from 1 to 5. In this way we are writing the sets in set builder form.